An arithmetic sequence has first term 60 and a common difference of negative 2.5. Given that the k term of the sequence is 0, so we're saying that u sub k equals 0, find the value of k. So we can use the formula u sub k equals u sub 1 plus k minus 1 times d. By substitution, 60, no, it's 0. U sub k is 0. And the first term is 60 plus, we have negative 2.5 multiplied by k minus 1. This is paper 2. So you can just use calculator, by the way, to find the value of k. So our k is equal to 25. Given that, okay, let me put this in a box. Now letter B. Let S sub n, the sum, denote the sum of the first n terms of the sequence. So you have u sub 1 plus u sub 2 plus until u sub n. That will give you S sub n. But we use k instead, so we have S sub n equals n over 2 first term plus the last term. We already know the last term. It's given in the problem. So S sub n equals we can replace n by k, and we have 25 over 2, 60 plus 0. So that gives us S sub n. Let's go back to S sub n because that is a question. That is what is stated in the problem. The maximum value is 750. This is paper 2, so you can use calculator in solving. You may attempt to do that manually, but that will require much time. Okay, at a school, 70% of the students play sports, and 30% of the students are involved in theater, and 18 to neither of these two activities. A student is elected at random. A, find the probability that the student plays a sport and is involved in theater. So we can visualize a problem. Let's say this is students playing sports, 70%, and those involved in theater, 20%, and then those who neither join these two activities, 18%. So 18%, that would mean 100% minus 18% equals 82%. So this part comprise 82%. So that 82%, okay, is a combination of 70% plus 20% minus the intersection here. Let's say that is x minus x. So our x, which represent that the student plays a sport and is involved in theater, is equal to how many percent? That would be equal to 8%. Okay, it's 90 minus 82%. So 8%, this is for letter A. We can see the intersection. You can also label this as intersection P equals 8%. Okay, for letter B, find the probability that the student is involved in theater but does not play sport. Let's take a look at this one. here, let's mean this part is for the theater. So the part that probability the students involved in theater only but does not play sport is this. So letter B, it's 20% minus 8% equals 12%. For letter C, okay, let's read this. At a school, 48% of the students are girls and 25% of the girls are involved in theater. A student is selected at random. Let G be the number of students is a girl, and let T be the event that the student is involved in theater. Find probability of girl intersection T. So let me use different color here. So for C, the probability of girl intersection T could be taken from here. 48% of the students are girls, and 25% of 48%. So this translates to 0.25 times 0.48, and this is equal to 0.12. Determine if the events G and T are independent. Justify your answer. So if they are independent, and there are two things that we consider, that the probability of G intersection T must be equal to probability of G times probability of T. This will make them independent. However, is it already independent? Let's try. So we have already solved this part, okay, and then we need to find the probability of G times probability of T. How many girls are there? 48%. 0.48 times in theater is 0.2. So this gives us 0.096. So are they independent? So our final answer is that PG intersection T is not equal to probability of G times probability of T. Therefore, not independent. So this shall be our answer. This one is only used to point out under what condition will you make them independent, but this is the final result. Okay, so problem number 5. The functions f and g are defined for x element of R by this and this one, where C is an element of R. Find the range of f. So how are we going to find the range of the y values of f? One thing we can do is to find the vertex of this quadratic function, because once we know the graph, then we can already identify all the y values are from here going up. This one, since it is positive, it opens up. So our vertex have h and k as the coordinates, where h is the same as negative p over 2a. So negative of negative 12 over 2 times 6. So we shall have 1 as the y value, x value. Now we solve for our k by substituting the values. 6 times 1 squared minus 12 times 1 plus 1. So we get our k equal to negative 5. So we have here negative 5. So meaning to say our y value starts from negative 5 going up, so it will be equal or higher than negative 5. Find, given that we have the composite function g of x less than 0, so we are asked to find the value of c. So let's do this. Okay, we have letter B. G of x will be negative of our f of x, 6x squared minus 12x plus 1, and then plus c. It says it must be less than or equal to 0. You can see that the graph, okay, let me draw to illustrate. So we have here 1 negative 5, 1 negative 5, and it has been flipped over. So we flip this over, this become, because of this negative, meaning to say it is reflected over the x-axis. So we shall have here this value. So it has been reflected, where this is negative, our y here at this point is negative 5 plus c. No, it becomes positive 5 now because it is reflected. Our y value here is from negative 5, it has been reflected over the x-axis, so it will be 5. 5 plus c. Some more additional, we don't know whether it's going up or down, but it's 5 plus c. So our 5 plus c is less than or equal to 0. Therefore, our c must be less than or equal to negative 5. That's the value of c.